So we've got an arithmetic sequence. We're told the third term, oops, so U3 equals 10 and U5 equals 16. So if we look at the formula booklet, we can see here that the nth term of an arithmetic sequence is U1 plus n minus 1d. So we've got it with us. Okay, so if we know that un is u1 plus n minus 1d, we can set up two equations. So we know that 10 is equal to u1 plus, and then I can work out the n minus 1 part, so that's n is 3 obviously in this case, so that's 3 take away 1 is 2d, and then for this one n is now 5, so this is 16 equals u1 plus 4d. As I said, you've then got simultaneous equations, so I'm going to call this equation 1, this equation 2, and do equation 2 take away equation 1. Let's line them up one on top of each other. Okay, so we're taking them away, so 16 take away 10 is 6. U1 take away U1 is nothing. 4d take away 2d is 2d. So that means that d is 3. Find the first term, so we can use either of the two equations that we set up. I'm just going to use this first one, equation 1. So I know that 10 is equal to u1 plus 2 lots of 3. So 10 is equal to u1 plus 6, which means that u1 is 4. Find the sum of the first 20 terms of this sequence. So again, going back to the formula, we're looking at the sum of an arithmetic sequence. Obviously we do have two options given to us here. We're just going to use this first, more commonly used one. This is the second one if we knew what the last term was. So part C, so it's the sum of the first 20 terms, so we're finding S20 equals 20 over 2 brackets 2 lots of 4. Obviously we just found the u1 plus, I'm going to do the 20 minus 1 in my head. Oops, that's 19 lots of 3. Oh gosh, it's not very clear, sorry. So then that's 10 brackets 2 times 4 is 8. We've got 3 multiplied by 19, so 3 times 10 is 30, 3 times 9 is 27, so that's 57. 8 plus 57 is 65. 10 times 65 is 650. Okay, so remember, obviously this is a non-count paper, so you would have to be able to do that all in your head, or pen and paper, obviously, if you needed to do 19 times 3. You could set it out like this. 3 times 9 is 27. 1 times 3 is 3, plus the carried 2 is 5. Right, question number 3. So we know that fx is x squared. We need to find the definite integral between 2 and 1 of fx all squared. I'm just going to write it here next to it to make it a little easier. So we're finding the definite integral between 2 and 1 of x squared, oh gosh, all squared. So that becomes integral between 2 and 1. X squared squared is x about 4 dx. So once that's now established, I'll move down here a little bit. Yeah, because I haven't got enough space. So we're finding a definite integral between 2 and 1 of x to the power 4. So we can actually integrate now, so we know we add 1 to the power and divide by a new power. So it becomes x5 over 5 between 2 and 1. So it's 2 to the power 5 over 5 minus 1 to the power 5 over 5. So that's 32 over 5, subtract 1 over 5, and that is 31 over 5. Right, the following diagram shows part of graph. Okay, so we're looking at between 1 and 2. Shaded region is enclosed by the graph. Find the volume of solid formed when R is revolved around 360 around the x-axis. Now you'll notice here that this first part was worth 4 marks. This formula here is showing it's the definite integral of fx all squared. Now if we go back to the formula booklet, and here on the calculus page, if we remember that the volume of revolution about the x-axis between A and B is given by pi y squared. Well, we've obviously just found the integral of y squared between B and A. So all we have to do now is multiply that answer by pi. So part B is simply going to be 31 pi over